That's good to know. I forgot to upload my other recording from last time. I don't remember where that is. Let me just check to make sure see if I can find where that is, and then I'll upload it really quick. I don't know if it's on this computer or the other one. Let's see, that would have been the 5th of July. It's not here. It's on my other computer, so I'll try to remember to get that uploaded. Sorry about that. I don't think I did upload it, so I'm doubly sorry. Anyway, so today being a review day, it is time to ask questions about the homework. I did get some labs from people, so thank you for that. For those of you who still have labs to finish up, make sure you get those to me and as quickly as you can so we can make sure that you get your grades for those. I will start entering those grades into my open math here hopefully this week. And let's see, we are in, what chapter are we in? I don't remember now. Let's take a look at the calendar. Looks like we're in chapter 9 right now. Does that sound right?
Yeah, that's right.
All right. Well, let's answer some questions. Who's got homework questions or concept questions or anything else? Anybody? You guys make this easy on me when you don't have any questions or anything for me to do. I haven't checked on everybody's progress on the homework yet. Well, that's why nobody's asking any questions, because hardly anybody's started the homework. You guys need to start the homework so you can ask your questions. Maybe my homework's just too easy. I don't know. That's possible, I suppose. Is my homework too easy? All right, let's take a look at the homework anyway and just kind of see what it's like here. We have different weight distributions on boards, on doors, on flag poles. Question 6 and question 7 tend to be questions that people struggle with. I will do one of them for you today. Let's do the cat question. This is question 6. Share my screen with you. So in question 6, we have this daring cat who's going to wander out the edge of this board, which is hanging off the edge of a pier, because there's a can of tuna out there or something. Sardines, it looks like. Can't blame him. I like sardines too. Maybe it's a she cat, I don't know. But we want to know how far this cat can go out before tipping the board over into the water. So it's often a good idea in a situation like this to define a distance first. We're trying to figure out how far the cat can go out from the edge. It says right here, how far from the edge of the pier can the cat go before it falls in the water? This is the thing that we don't know. This is a distance from the edge to some distance out there we don't know. We're going to give it a name. We're going to call it X. And we do know some other things. They do tell us the mass of the cat. We'll call it mass of cat. Oh, I love when my computer is taking its time to catch up with things here. There we go. So mass of the cat. We also have the mass of the sardines over here. They tell us that. They also tell us how far the board has extended beyond the edge of the pier. So they tell us this distance here is 1.5 meters, and maybe this thing will draw for me. We'll call that distance like D or something. Who knows what we'll call it. There we go. I don't know why this is giving me trouble. I think it's Zoom struggles with this sometimes, but anyway. So that's a distance D that they do tell us. They also tell us the mass of the board. The board has a mass here as well. So we have these we also know the total length of the board. So the total length of this whole board here we'll call L. And so what do we know? That, I mean, this is an equilibrium problem. We have the two conditions of equilibrium that say all the forces have to add together to be zero. And all of the torques have to add together to equal zero. So forces in X and Y, of course, if we define our X and Y to be like this, we know that the forces in the X direction aren't going to be a problem because we don't have any forces in the X direction. The only thing we have here are weights, and weights point down in this direction, in the Y direction, the negative Y direction in particular. We don't have any forces going back and forth. We'll consider the friction of the cat's paws on the board to be very, very small compared to the friction between the board and the pier. So as the cat walks forward, he's not going to make the board slide backwards or anything. It's just not going to be much effect there. So all we really need to worry about are the vertical forces, and the vertical forces are going to be as such. Right in the middle of the board, acting downward, will be the force of the board's weight. So the weight of the board, straight down like that. At the position of the cat, wherever they're at, and that's a variable position, we'll call that position X. Right now, X is equal to the edge of the pier, but it'll be changing as we go on through this problem. But the weight of the cat is going to act wherever the cat is at any particular time during the problem, the weight of the cat. And then we have the weight of the can, which acts out here, and it just sits there until such time as the cat gets it, if the cat ever gets it. Weight of the sardines. And each one of these weights is equal to a mass times an acceleration, or mass times gravity because it's weight. So this is the mass of the sardines times gravity. This is the mass of the cat times gravity. And this is the mass of the board times gravity, and they're all pointing down. And we might realize right away that the forces in the Y direction, if we add up all the forces in the Y direction, since this board isn't going anywhere in the Y direction, it's going to equal 0. And all that's going to tell us is the value of the normal force of the pier pushing up on the board, which is not really helpful because we're not going to use that normal force for anything that I can think of. The only thing we might use it for is to calculate the amount of friction between the board and the pier, but they've not told us anything about the frictional coefficient, so it's not going to be helpful. So this is not going to be very useful to us. However, the sum, if I can get this thing to start working here, come on. Just takes its time to work here, doesn't it? The sum of the torques is definitely going to be something worth looking at. And we want the sum of the torques to equal 0 because we don't want this thing to rotate. As soon as this thing starts to rotate, the cat's going in the drink. So we want it to be equal to 0 for the equilibrium condition. And as the cat walks out there, we're going to have some things. For each of these torques, though, remember that each torque has to have a couple of different things. We have to have the distance to the force that causes the torque, which we call R. We have to have the force that causes the torque, which in our case we call these different weights, W's. But we also have to add the angle between the distance vector and the force vector, theta. It's not cosine theta, it's sine theta. So RF sine theta, we have to have three things: distance, force, angle. Well, all the angles between the distances are going to be 90 degrees because we're going to be measuring distance along this board, and the angle between these weights and the board are all 90 degrees. So this sine of 90 degrees becomes 1, and we just left with the distance times F. Well, what are the distances for each of these forces? Well, it depends on where we consider our 0 point. Where are we going to say 0 is located? Well, we can say 0 is located at this end of the board, or at the middle of the board, or at the edge of the pier. Any of those would work. We could also say from the end of the board. But what we really want to do is set up our problem so that it makes sense for the answer. It says, how far from the edge of the pier can the cat go before the board falls in the water? So we might as well make our 0 point the edge of the pier so that when we get an X, it tells us the answer, and we don't have to do extra calculations to figure out the answer. So we're going to figure out all of our distances from the edge of the pier, which means I need to redraw this because this is a mess. So I'm going to go ahead and redraw this picture over here and make it a little simpler. There's our board. There's our pier, maybe. There we go. There's our pier. We have the middle of our board right here. And we need to know how far this force is from here, because that's our first distance. This is R to the board, because going to the center of the board. We need to know our R to the where the cat is, which we're going to call X. The distance from the edge to the cat is X. Let's see if I can make this happen. There we go. Come on, dumb thing. Why does this thing struggle so much? So this distance will be, I have no idea why Zoom is struggling so much, but it is. And then we need to know the distance from the can to the edge of the board, this distance here. We actually have most of these distances. We do know what the distance is from the can to the edge of the board. That's the D that they gave us, the distance from the how far the board sticks out. It sticks out 1.5 meters. So that one is 1.5 meters. And again, I'm not drawing anything. Stupid. I can't even tell what I've done. I can't tell that I'm drawing like I'm drunk because I can't see. It'd be helpful to see this thing. 1.5 meters. I think I need to update my Zoom probably. It's probably, I never update things, and so I often run into problems here. So we know that distance to the can. So that's going to be our R to the, we'll call that our R to the can. We'll need that to calculate our torque for the can. So let's go ahead and calculate the torque for the can first. The torque for the can, first of all, it's going to have a sign. The torque is either going to be positive or negative. Remember, the positive means that the torque, the force from the can is going to cause it to go clockwise or counterclockwise if it's positive, and clockwise if it's negative. Well, this can is going to try to make this board rotate like this, around this way, and that is definitely in a counterclockwise rotation. So that will be positive. And I'll explicitly write that just so I remember that I actually checked that. So that's definitely, this is definitely a positive torque, and the force involved is the weight of the can. Dang it. So the weight of the can, and the distance is R to the can. And we know that the R to the can is the D that they've given us, which is the 1.5. And we know that the weight of the can is the mass of the can times gravity. So that gives us our first torque, and it's positive. As if that's gonna work, okay? The second one, X, that one's easy. The X, which is the distance to the cat, that one's also easy because we know everything there except for X. So we can go ahead and write that one down. The torque, maybe. Goodness. Sorry, I messed up something that this is making me crazy. Why is this giving me so much grief? Maybe I have too many things going on my computer. Not likely. This computer can handle just about anything. But it can't handle Zoom. I wonder if Zoom is struggling all over the world with things like this just because it's becoming too much use. So this is sardines, not C for can. Because remember, we used S for sardines instead of C for can. I got that mixed up a little bit. And then this one will be torque of the cat. Oh man, this is pissing me off. Why is this thing not working? What is going on with this stupid drawing tool? I've never had so many troubles with this thing. It's not even registering that I'm using Zoom. That's the problem. Zoom is like stuck. Zoom is not doing what it should be doing for some reason. I don't know why. Why doesn't it know I'm using Zoom? Now it knows I'm using Zoom. So, right, maybe it'll work now, maybe not, who knows. So the torque for the cat, the distance to the cat, and the cat, as the cat comes out here on the edge, it's also going to cause some impending counterclockwise motion, so it's definitely be positive. The distance that it's going to go is X. That's the thing we're trying to find out. That's our big question mark. And then the weight of the cat is the force. So this becomes X mass of cat, where this is mass of sardines up here. Mass of cat times gravity. So we got two torques. The third torque is from the board, right? The weight of the board is over here on the right side. And so the weight is actually trying to push the board in the opposite rotational direction. It's trying to make clockwise motion. So the torque, good night. Gotta be kidding me. This is gonna make me crazy. You gotta be kidding me. So the torque from the weight of the board is going to be negative now. It's going to have a negative value. And it's going to be negative the distance, this RB here. Ay, ay, ay. This is making me so angry. I don't understand what's going on with Zoom right now. If Zoom starts being a program that doesn't work anymore, I'm going to, I don't know what I'm going to do. I'm going to firebomb my computer or something. It's this RB thing, and I'm going to have to like, I don't know why it's doing this. I don't get it. So RB times the weight of the board, which is mass of the board. I'm just going to write it out, times gravity before my pen stops working again. The RB, though, is the thing we don't have a number for yet, but we can figure it out. We can figure it out because we know that from the halfway point of the board all the way to this side is half of the length, which is given to us. They tell us the length is 4.6 meters long. So we can take half of this length here, and we can subtract off the two things that are taking away from this, or we can subtract off the thing that's the difference here. The difference is this 1.5 meters, right? So we take RB and we subtract off R of the sardines, or the distance here, 1.5. So that one can be done. We can go ahead and make that work. So that ends up being, in this case, it ends up being the length of the board minus R to the sardines. If you can make that come alive here for good night. Looks like I'm like blind and trying to draw or something. I don't get it. Why is this being so stupid? R sardines. L minus R sardines. There we go. Kind of looks right-ish. So that's our distance, and that thing has to be now multiplied by the mass of the board times gravity. Right? Now these are our three torques, and they have to add to be 0. So we do that. We have our distance, the D, which is 1.5, which is also R to sardines, times MS. It's really going to make me angry. I am going to write a letter to Zoom and tell them that they're stupid. We now have D times M mass of sardines. All of these have gravity multiplied by them, so I'm going to put the gravity in at the end. Then we're going to add. Maybe. We might add something, but not likely, because this thing sucks. We're going to add to it X times mass of the cat. We're going to subtract from that, because this last one is minus. It's a minus one. And yeah, like we're going to be able to actually make that happen. We're going to subtract from it the L minus the distance to the sardines, which is also D. We'll put it in as D instead of R sub S, times the mass of the board. And we multiply this whole thing times G, and it has to equal 0. But since you can divide both sides by G, we can just set the whole thing equal to 0. And this equation has every number in it, numbers that we know except for X, and you can solve that one. This is the only thing we don't know. You know that D is the distance that it hangs off the end, that's 1.5. You know L is the length of the total board, which is 4.6. You know the mass of each one of these things. You can solve for the distance off the edge of the pier, and you're done. Which they actually call D, which I didn't look at, but anyway. But here all we're doing is we're setting up that sum of the torques equation and solving it. That's all we're doing in the end. We do have to, figure out each one of the torques and then put them in the equation, make sure we know the signs correctly. And then we had to figure out this distance here by taking half the board, subtracting off the board that's hanging off the edge, and that tells us how far we are from the edge to the center of the board. But besides that, it's just that one equation, solving it for the distance off the edge of the pier. And that is that. Does anybody else have any questions about any other problems? Since that was my question about that problem. Would anybody else like to ask a question about this problem or any other problem? Are we good to go? Any questions here? Can I erase this? Stop using the drawing tool, which sucks.
I'm good.
Well, if there are no more questions, final call. If there are no more questions, we are done. And we can turn you loose to finish up the homework. We will reconvene on Monday, and we will see you then. Have a good weekend.
You too.
Thank you.